What's up, YouTube? I'm going to try and make this video as quick as I possibly can. I know I've said that before and failed utterly at it, but um, icecoalman Smith left me a comment on my last video and asked me if it was possible to heat treat simple carbon steels, 1095, 1080, 5160. Not quite as simple. If you could do that without a computer-controlled heat treating oven. And the short answer is yes, you can. And the long answer, you're gonna get. He said that I sound like I'm very educated on heat treating. I would say that I have just screwed a lot of stuff up, learned from my mistakes, and then wondered why those bad things happened. I have read quite a few treatises on heat treating, and I actually actively go out and look for heat treat information that is not derived from steel companies' data sheets. Any engineer that works with steel and has to account for the heat treatment of that steel will tell you that the data sheets that you get from a steel company are they are for display purposes only. They're to give you a basic idea of the qualities of the steel. They're definitely not specific to the application that you might be designing your part for. And since I am designing knives, those are my part. You essentially have to work at it on your own to find the appropriate heat treatment for whatever steel it is that you're using for your specific application. It's one of the many splendid joys of taking metallurgy seriously. Can I tell you how many really boring books? Well, you would find them boring. I find them fascinating. Most people, my wife, she's like, how can you sit there and read Krauss's The Principles of Heat Treatment of Steel again? I'm like, because this is the good shit, babe. This is the seminal work. I'm sorry for that geek out. Here, look at a knife while I talk. Ooh, look at that. Little kitchen knife. How you doing? Yeah. I finished that today. Carbon fiber with some gnarly organoforming on it. And 690 blade. So anyway, back to, that's SM100 there. This is actually the piece of steel not steel. It's not steel. Stop calling it steel, Gavco. It's not steel. It's nickel titanium. And I like the way you say titanium. Sorry. I'm so sorry, Mike. Yeah, this is going to be the St. Jude's charity knife blade. There it is. Look at that. Awesomeness. That's what I'm planning on doing. I don't know if I'm going to do the dragon claws in there. It might be a little... I don't know. We'll see what happens. We'll see how crazy I get when I'm doing it. Anyway, back to simple carbon steels and heat treating them without a heat treating oven. So it can be done. There are some things that I would recommend. You can use an oxyacetylene torch to do it. I'm sure you've seen a YouTube video where dude is heat treating his O1 bleed with a oxyacetylene torch. Doable, not super duper effective and repeatable, and maybe not the best heat treat ever, but doable in the pinch, in lack of other things in lieu. What I would rather see happen, and what I have done in the past, is either acquiring some fire bricks, also known as refractory bricks. You don't have to mortar them together. You can leave them loose, and then you configure it into some kind of oveny looking thing. And you can configure it to whatever size blade you're doing. And then using some sort of torch. Oxyacetylene is actually a little hot, and if you have it blaring down right on the blade, you can actually melt the thin sections. I know from experience. It's always exciting when you work hard on something and then melt it. Yeah, the memories. Anyway, what I actually used to do is I went to Harbor Freight, what a great store, and got a weed burner, Or the other thing that works is a roofing burner that you'd use to melt tar on a roof. They hook up to a standard propane tank, the big one like you use on a barbecue, and they actually have an enormous amount of output. If you do it right, at full blast, those things will kick out 3,000 degrees of heat. They also burn a lot of propane, I'll warn you of that. But you can use them, and they actually, and set the little nozzle on it, and it will actually give you a fairly continuous, fairly consistent amount of heat. And then if you've encased that in some kind of fire brick type structure, it'll hold that heat in, and you can get fairly good even heat treats on blades with that. I did it for many years. It works very well with the simpler carbon steels because they have particularly low critical temperatures, which is the temperature where they begin converting to a phase of steel called austenite. And then austenite is the thing which actually creates martensite when you quench it. Don't get. It's taking every bone in my body not to get technical with that, but I'm going to spare you. So essentially what you're going to do is you're going to stick your blade in your impromptu oven, create some kind of heat source in there, and allow it to heat up. The color that you're looking for in your steel as it's approaching the heat, the level of heat, the temperature that you want. Temperature is probably the best way to describe that because it's actually a description of the amount of energy in something. So let's use temperature. That's a little more scientific. We can all handle temperature. So the temperature that you're going to be wanting to get that steel up to, and I mean for simple steel, it's in the 1500s Fahrenheit is where it starts. Usually, if you're anywhere inside your little oven setup, if you've achieved anything between 16 and 18, you're looking all right. If you can get up into the 1900s, then you're definitely going to be there. So once it's been in there, and you're going to kind of look for a color. The Japanese say, there's a Japanese saying that you'll know the blade is ready when it glows like the rising sun. And it's a pretty good description of the color. It's actually a fairly bright orange color that we're looking for. And once you see that color through the entire blade, then you're going to want to let that sit in there between 7 and 15 minutes, depending upon how big the blade is. And then you're going to be wanting to quench that. Another way that people check is if it loses its magnetism. So literally, they will stick a magnet in there and see if it still attracts, because the structure known as austenite is non-magnetic. It loses ferromagnetism. So that's usually one way people check to see if they're achieving austenite. And austenite then becomes martensite when you quench it. And so I would recommend for quenching that you use an oil, maybe a plant-based oil like peanut oil, olive oil, vegetable oil. You can use corn oil. The reason I would recommend that is because the petroleum-based products like engine oil, what is that other stuff? Brake fluid, transmission fluid, they stink really, really bad, which is not particularly good for you, and they tend to flare up and burn. Yeah, I've had some good old oil fires in my past, so be aware of that. Then once you've quenched, and don't use water, don't even try, just don't do it. Yeah, the 10 series is not a particularly good water hardening steel, and there's a really high likelihood you're going to get a warp, and there's also a really high likelihood that you'll actually rip the steel to pieces if there's unevenness in the heat distribution in the blade. I've seen it happen. It's crazy. It just rips itself to pieces. It's nuts. So once you've had them quenched and they have cooled down to where you can touch them, then they need to go in an oven. Just a regular convection oven will be fine. But you are going to want to check and see if the temperatures that it displays on its dials are actually real. A lot of times the dial on your oven will say that it's at 450, or the digital display, as some ovens are, and it'll be lying to you. It'll really be like 400 or 500. There's a big wide range of plus minus in temperatures, and then a relation to the dial setting on a standard convection oven. So you can check that by having one or two oven thermometers thrown in there while it's heating. And then if when you're pretty certain that you've got it to a stable temperature, and then you know where your dial is set, then you can pick a reasonable tempering temperature, and you can find those online. Those steels are very old steels. I mean, the 10 series is over 100 years old, and 5160 isn't exactly a spring chicken. I can't recall exactly when that steel was formulated, but it's really old. I mean, it's probably 80 years old. It's an old steel. So there's a lot of data on them. I know that in the past I've had good success with 5160 at 400 degrees and sometimes 450. And you're going to want to temper them for about 2 hours at a time, and you're going to want to do it twice. So it goes in for 2 hours, sits, you pull it out, let it air cool, you put it back in for another 2 hours. That's a very safe way to temper, and it usually yields consistent results. I do a lot. It's called a 2x2 or duplex, and I do that almost all the time. And there you have it. Those are my suggestions if you're going to do it without a computer-controlled heat treat oven. It's doable. I mean, human beings have been heat treating steel for 3,000 years, so you can do it. You can get all cavemen about it. Well, they weren't really cavemen. They were fairly advanced. Oh, no, don't. It's tempting to talk about some metallurgical history with you, but I won't. I shall restrain myself for the moment. So I hope that was a pretty good answer and not too complicated. I tried. And if you have any more questions, you know what, you should email me. icecoalman, email me, okay? And then I can just write you a thesis on it. It'll be great. You'll be reading it and wanting to gouge your eyes out. Joking. Alright, YouTube. See you later.